So for this example problem, we're given a geometric sequence and we need to find its explicit formula. So let's first remind ourselves what that general explicit formula looks like. That to find the nth term in the sequence, we'll take the first term and then multiply that by r, the common ratio, n minus 1 times. So r is our common ratio. And the majority of the work for these problems is going to be to find that common ratio since we're given the first term. So we already know what a of 1 is. That's just 1/2 in this case. And to find that common ratio, remember that you can set up an equation. We can take 1/2, multiply it by r, and set that equal to -4, and then solve the equation. Or you could just take any term in the sequence and divide it by the term before it. So for instance, we can take 32 and divide it by the term before it, which is -4. And 32 divided by -4 is simply -8. But we could have done that with any two terms. We could have taken -4 and divided it by 1/2. And 1/2 goes into 4 8 times, and we have that negative that carries along. So we would get the same answer, and that would be true for any two terms. So we know our common ratio, and we know our first term, so let's just plug those in and come up with our formula. So our geometric sequence, a of n, is equal to that first term, which is 1/2, multiplied by that common ratio, -8, raised to the n minus 1 power. So this is what we think is our answer, but to know for sure, we're going to want to check this. And to check this, we just got to find a specific term in the sequence and plug in that n value into our formula and see if we get back the same number. So let's use the third term this time, since we know that a of 3, the third term in this sequence, is equal to 32. So if we plug that into our formula, a of 3, we get 1/2 multiplied by -8 to the 3 minus 1. And if we simplify that, we have 1/2 times -8 squared. And -8 squared is -8 times -8, which is positive 64. So you get 1/2 times 64, or 64 divided by 2, which is 32. And that's what we expected. So since we got back exactly what we were hoping for, we can feel confident that this formula is correct.